All right, so first question is name opposite rays, and we're working through the 1-4 notes for you guys that are at home today. So it says name the opposite rays. So we're going to start at the end point, and we'll start with J out to D. That's one of our two opposite rays. And then we'll go J and Z, which goes out in the other direction. Because opposite rays are two rays that point in complete opposite directions and share an endpoint. If I go to B, B says, what are the measures? What is the measure of the angle formed by the opposite rays? All right, so if we went to the halfway point up here, that would be 90 degrees. And then we go another halfway, that's another 90. So we're looking at 180 degrees. Opposite rays are always going to form a 180 degree straight angle. If I go to part C, what is another name for DJ? So if I look up here, we have D and J, D being the endpoint. So we need to keep D, because it's our endpoint. And we need to pick another point that's out on the ray in the direction it's pointing, which would be Z. So DZ. In D it says, start with that same straight angle, D, J, Z. All right, and then have JM bisect the angle. So that means cut it perfectly in half. So we're going to draw JM in here. So it cuts it in half. And it says, what would the measure of DJM be? So if I look at DJM, that's halfway, so that's going to be a 90 degree angle. So measure of angle DJM equals 90 degrees. And it says, what type of angles are formed? So the two angles, they're both right angles. So for the second question, we could say right angles. And another option that we could say is we could say that they are supplementary because they add to 180. All right, and then another name that we could really give them is a linear pair. All right, so a linear pair are two adjacent angles, two angles that are touching, that form a straight line, which these two would. So really, all three of those would be solid answers for part D. All right, if I move over here to example 2, example 2 says, name the three angles in the diagram. So we have the two smaller angles, angle 1 and 2 here, and then the big angle. So if we're going to label those, the angle 1, the first smaller angle, is angle AQB. All right, we use 3 points. The middle is always the vertex. The second small angle is going to be BQC. And then the large angle is going to be angle AQC. So that gives us our three angles that are involved in that picture. Next one says name angle AQC, so the large angle in another way. The only other way I could label that is I could just say angle Q. All right, we can only do this when it's dealing with one large angle. We could not label the small angles, angle 1 or angle 2, in the same way. All right, so it has to be the only angle or the largest angle in order to just use the vertex. Part C says, why can't you say Q in reference to this diagram? All right, in reference to this diagram, there's three angles at play, so you can't tell which of the three angles.
Thank you.
What day is it?
So it's hard to tell which of the three angles. All right, if I go to D, D says, name the sides of BQC. All right, so BQC, the sides are two rays. We have the ray here, and we have the ray here. So we would say QB and QC. All right, both are going to be our rays that form the sides of that angle. In E, it says, what is the vertex of BQC? So in BQC, the vertex is where those two sides meet. So that is at point Q. All right, what you're going to notice is that is always the middle value. All right, you're always going to have the vertex at the middle value. All right, so that covers page 1 of our notes from this section. I'll be back in a minute with page 2.